It's hard for us humans to truly grasp how huge space really is. We feel safe in our little cosmic neighborhood, the solar system, where familiar planets like Jupiter, Mars, and of course Earth are our everyday landmarks. But far beyond that, more than 18 billion kilometers away from the sun, past the edge called the heliopause, lies the cold, empty stretch of interstellar space. So far, only 2 spacecraft made by humans, the Voyager probes, have ever crossed into this deep space. And until recently, only 2 known visitors from beyond our solar system have come in the other direction, entering our neighborhood from interstellar space. These were the mysterious object Oumuamua in 2017 and Borisov in 2019. Their arrival sparked excitement, and maybe a little worry, since they came from places we can't hope to visit ourselves anytime soon. After those encounters, things quieted down for a few years. But now, a new discovery has grabbed our attention again. In this video, we'll dive into everything we know about NASA's newest find, Comet 3I Atlas. This is only the 3rd time we've seen an object like this from outside our solar system, and it's set to get closest to the sun before the year ends. While 3I Atlas has had several names since it was first spotted, new information about where it came from and where it's heading has turned this once ordinary-looking space rock into something really interesting. On July 1st, the Atlas Survey Telescope, funded by NASA, was doing its regular job, scanning the skies to find moving objects. ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, uses 4 telescopes spread across Chile, South Africa, and Hawaii. Each night, they take about 800 pictures of the sky. So far, they've spotted over 1,200 near-Earth objects that will come within 1.3 times the distance between Earth and the Sun. But on that night in Chile, the telescope at Rio Hurtado spotted something special. What makes the ATLAS telescopes unique is their ability to look at the galactic plane, the bright, flat area of our galaxy where most of its stars and mass are found. Other surveys like Pan-STARRS and the Catalina Sky Survey usually avoid this area because it's too bright and hard to photograph properly. From the direction of the Sagittarius constellation, the ATLAS telescope took 4 quick images, and they saw an object heading straight for our solar system. At first, this visitor was labeled A11PL3Z. The Minor Planet Center in Cambridge, Massachusetts, the official group that names and tracks small objects in space, noticed it right away. They shared all the details about the object's past sightings and its path through space. As astronomers studied the data, they realized this was not a completely new stranger after all. It turned out that the Zwicky Transient Facility in California, along with the other 3 ATLAS telescopes, had actually spotted this object earlier, going back to June 14th. Using all this information, the Minor Planet Center, NPC, figured out that the object follows a very unusual, stretched-out path called a hyperbolic orbit. This meant it came from outside our solar system, interstellar space. Because of this, it was named 3I Atlas, the 3rd known object from outside our solar system to enter it. At first, the NPC wasn't sure if this object was an asteroid or a comet, but after combining all the data, they found it had a coma, a fuzzy cloud of dust and gas around it. This happens when ice on the object's surface heats up and turns directly into gas because of the sun's rays. This coma is something comets usually have, so it also got the name C2025N1. The NPC has asked for more observations to better understand its path, so astronomers are expecting lots of new information soon and are very excited about it. Michelle Bannister, an astronomer from the University of Canterbury in New Zealand, said that studying the last 2 interstellar visitors was a huge boost for science. She expects this new visitor to teach us a lot too. But what do we already know, and what do scientists hope to learn? First off, there's no need to worry. This comet isn't a danger to Earth. At its closest, it will still be about 1.6 astronomical units, or AU, away, which is more than 600 times farther than the moon is from us. So what kind of trip is this comet on? As mentioned, 3I Atlas has a very stretched out orbit with an eccentricity of about 6. To explain, an eccentricity of 0 means a perfect circle, while any number above 1 means the object moves fast enough to escape the gravity of what it's orbiting, traveling freely through space. With an eccentricity as high as 6, this comet has one of the most extreme orbits ever seen, which helps explain how it has traveled so far to reach us.
Even more surprising is how fast it's moving. Right now, it's flying in at about 58 kilometers per second. To put that into perspective, that's like running across 580 soccer fields every second. This speed makes 3I Atlas the fastest interstellar comet we've ever observed. For comparison, the earlier visitors, Oumuamua and Borisov, moved at slower speeds, 26 and 32 kilometers per second, because their orbits were shaped differently. Because 3I Atlas is coming in so quickly, astronomers were eager to find out exactly where it's headed. Its orbit is centered on the Sun, heliocentric, so scientists can predict its path as it approaches. On October 30th, the comet will come closest to the Sun at about 1.4 AU, just inside Mars's orbit. In graphs showing its path, you can see the comet's curved approach as it passes Mars and then heads back out into space. Compared to Oumuamua's closer flyby in 2017, 3I Atlas won't come as near the Sun and will follow a route more like Borisov's. Once astronomers confirmed the comet's interstellar origins, they used telescopes around the world to learn more about it. In particular, the Las Cumbres Observatory LCO telescopes are built to watch short-lived space events like comets brightening suddenly. Using two smaller 0.36 meter telescopes in Hawaii, astronomers arranged to observe 3I Atlas for an hour. The goal of the observation was to study how the comet's brightness changed over time and to figure out if it showed any signs of spinning. When a comet rotates, its brightness can vary depending on its shape or which parts of it are more active. For example, if it has uneven surfaces or bright spots that face Earth at certain times, it can appear brighter or dimmer. By tracking how its light changes regularly, scientists can figure out how long it takes to complete one full spin.
Using the Las Cumbres Observatory LCO, telescopes found that this comet rotates roughly once every 29 hours. However, just like much of what we know about 3I Atlas, this number could still change as more data comes in. Interestingly, unlike Oumuamua, this comet had a very steady brightness. Its light curve didn't change much. Over the 29-hour period, its brightness only varied by about 0.2 magnitudes, which is quite small. But despite the low variation, 3I Atlas is still very bright. In fact, it's the brightest interstellar object we've seen so far. Until the end of May this year, the comet was barely visible, with a magnitude of around 20. But shortly after that, and by the time Atlas officially discovered it, its brightness had increased to around 17.7 to 17.8 in the Atlas O filter, which detects light between 560 and 820 nanometers. And brightness isn't the only notable thing, it's also big. Based on how much sunlight it reflects, its albedo, scientists estimate that the solid core, or nucleus, of 3I Atlas is around 10 kilometers across. That makes it about 10 times larger than Oumuamua, and even bigger than Borisov, which was estimated to be just 1 to 2 kilometers wide. On top of that, this comet is active. As mentioned earlier, 3I Atlas has a faint coma, a hazy cloud of gas and dust that forms when the sun's heat causes ice on the comet to turn into gas. You can see this glow as a fuzzy circle around the center of the comet in some images. In those images, the stars in the background appear streaked because the camera was tracking the comet's motion. But the coma isn't the only thing. It also has a tail. The Minor Planet Center reported a short tail about 3 arcseconds long, pointing at an angle of roughly 280 degrees. Since it's small, the tail often blends into the coma and can be hard to spot. Thanks to today's technology and global communication, people all over the world, from professional astronomers to hobbyists, are helping track and study 3I Atlas. New findings are constantly being shared. For instance, the Astronomer's Telegram, an online platform where scientists and astronomy fans post updates, is full of fresh observations. Astronomers Miguel Alacon and their team recently shared more accurate measurements of the comet's tail, estimating that it stretches over 25,000 kilometers. Their report, along with others, has given us some amazing images of this rare visitor from deep space. So far, we've talked about how bright it is, how it spins, and the activity we've seen from it. But what about what it looks like? In terms of color, 3I Atlas is similar to the other 2 interstellar objects we've seen. Like Oumuamua and Borisov, this comet reflects more red light than the sun does, and is also slightly redder than D-type asteroids, which come from the outer part of the asteroid belt. Since the comet is active, some of the red light we're seeing is likely coming from the dust in its coma.
A similar thing happened with Borisov. Its glowing coma was so bright that it overwhelmed the light coming from the comet's core, making it hard to study the nucleus itself. As 3I Atlas moves closer to Earth, astronomers expect to get better readings and confirm if the same thing is happening here. For context, back in 2020, scientists observed that Borisov was throwing off dust at about 50 kilograms every second. That high level of dust activity explained why the nucleus was hard to detect.
The discovery of 3I Atlas also gave astronomers a chance to rethink how many of these interstellar objects might be drifting through space. After it was spotted, researchers published a paper estimating that there are only about 0.001 interstellar objects for every cubic astronomical unit of space. That's a much lower number than what earlier estimates suggested after the discoveries of Oumuamua and Borisov. This new estimate is based on the fact that the Atlas system has been scanning the sky for about 3 years, and in that time, it's only spotted one such object. Of course, this number might change. There could be smaller interstellar visitors that slipped past unnoticed, or it's possible that these objects give off a signal that Atlas isn't designed to detect. Even though it's not a perfect number, this kind of estimate is still useful. Every time we find one of these rare objects, we get a chance to improve our understanding and update these figures. So far, we've looked at what we know about 3I Atlas, but as is often the case in science, new discoveries bring new questions. What can this comet still teach us, and how can comparing it with earlier interstellar objects help? Thankfully, astronomers now have 2 earlier examples, Oumuamua and Borisov, to compare this one with. We've talked about both of those in other videos, so be sure to check them out if you haven't already. Those videos go deeper into how these mysterious space travelers are alike and how they're different. But let's explore some key takeaways again, especially what those differences might tell us about where these objects come from. One clear difference is that 3I Atlas seems to be less active than Borisov. When Borisov was observed, it was giving off more and more dust. Its coma was growing by about 1% per day. That meant it had been active for around 100 days before it was even discovered. Borisov also had a much longer tail, stretching about 140,000 kilometers into space. One idea is that 3I Atlas just hasn't gotten close enough to the sun for its icy materials to start turning into gas, which would increase its activity. But there's a catch. Borisov started showing strong activity when it was still 4.5 AU from the sun, and 3I Atlas is already closer than that. So it seems unlikely that it's just a matter of distance. Still, not all interstellar objects are alike. Oumuamua, for instance, didn't show any signs of activity at all. It was a solid rocky object with no visible gas cloud or tail. Scientists are still trying to figure out why. Some now think it may have been releasing gas in a way that didn't kick up much dust, so telescopes couldn't pick it up. But since 3I Atlas does have a coma, that theory can't explain everything. With such different features and behavior among these 3 objects, it's clear that they don't all come from the same type of place or form in the same way. Understanding their origins remains one of the big questions astronomers are trying to answer.
Oumuamua's long, cigar-like shape sparked a lot of interest and debate about where it came from. Some scientists thought it might be a leftover piece from the early days of another star system, shaped by intense gravitational forces. Others believed it could be a broken chunk of a planet, or maybe even a clump formed by smaller pieces coming together. Borisov, the second known interstellar object, also raised questions. Its chemical makeup didn't match what we usually see in comets from our own solar system. It had much more carbon monoxide than water, which led scientists to believe it may have come from a place rich in carbon. Based on this, some researchers suggested that Borisov may have formed in a system with a red dwarf star. These stars are cooler than our sun, making it possible for carbon monoxide gas to freeze and become part of a comet. As for 3I Atlas, it's still early days, so we don't yet know exactly where it came from. But since it's already showing signs of activity like Borisov did, we might eventually detect similar gases like carbon monoxide, which could suggest it has a similar origin. What we do know for sure is that 3I Atlas is an unusual and fascinating object from beyond our solar system. While it shares some traits with Borisov and Oumuamua, it also has unique features that set it apart. Because of that, scientists see it as a fresh opportunity to make new discoveries, and who knows what we'll learn from it. Since these objects are so rare, it could be a very long time before another one shows up. Now that you've got some background on 3-Eye Atlas, you might want to try spotting it for yourself. If you have access to a telescope, you should be able to track it in the night sky from September until it disappears behind the sun. It will reach its closest point to the sun, called perihelion, on October 30th, and then reappear in early December for another chance to see it. But don't worry if you don't have a telescope, you can still follow along. NASA's JPL Horizons website lets anyone track the comet's path in real time. When we last checked on July 4th, it showed the comet's exact position around the sun. Why not look it up now and see how far it's traveled since then? If you do, drop your findings in the comments. We'd love to hear about it. Until then, we're just as curious as you are to find out what more this rare interstellar visitor can teach us. It's come a long way across space, and chances are it's carrying some pretty incredible cosmic stories. Thanks for tuning in. We'll see you in the next one.